Here we're going to discuss writing a parabola or a quadratic function in standard form and then getting some information from that standard form and then graphing it. So remember that a quadratic function is one where the right-hand side is a quadratic polynomial. So for example, f of x is equal to the general quadratic function can be written as ax squared plus bx plus c. And so the right-hand side is a second degree polynomial. Now, when we write it in standard form, what we mean is this form. F of x equals a, the same a as right here, times x minus h squared plus k. So that form that I just wrote, that's the standard form for a quadratic function. And when you've written it in standard form, it's still a parabola, of course. The vertex is obvious. Once you've written it in standard form, it's the coordinates, it's the ordered pair hk. So the vertex is h comma k. And then it opens up if a is greater than 0. So the parabola opens up if a is greater than 0, and it opens down if the number a here is less than 0. Now, of course, because these are the same a, you can tell right away just in this form as well if it opens up or down. So let's go ahead and let's do an example of expressing a quadratic function in the standard form and then getting some information and then graphing it. So let's express f of x equals 2x squared minus 12x plus 13 in standard form. Find the vertex, maximum or minimum value, and the x and the y-intercepts. Let's sketch the graph as well. And as we know, not every quadratic function has x-intercepts. So we'll see if this one does. All right, so to write this in standard form, first let's start with the form we've got. F of x equals 2x squared minus 12x plus 13. So what you want to do is you want to complete the square using these two terms. So to complete the square, you want the coefficient attached to x squared to be a 1. So we're going to factor out a 2 of just those terms. So we're going to write this as 2 times x squared minus 6x, and then plus 13 is off to the side. So what we're doing is we're just concerning ourselves with the quadratic and the linear term, that is x squared and x. And we want the coefficient of the quadratic term, that is of the x squared term, we want that coefficient to be a 1, which is why we factored out a 2. If this already was a 1, then I wouldn't have to do this step. So once you've done that step, if necessary, now you want to complete the square using those two terms, the x squared and the term containing x. And the way you do that is you take half of the coefficient attached to x, so in this case negative 6, and half of that is negative 3, and then you square that. So when I square negative 3, I get 9. So I'm going to add and subtract 9 within the parentheses. So I'm going to get 2 times x squared minus 6x plus 9, and then minus 9, all within the parentheses, and then plus 13. It's important that it's in the parentheses for the reason you're going to see soon. Okay, and then what we do is we acknowledge that by adding 9, we've completed the square. So these first three terms here, they form a perfect square. So I'm going to change the parentheses to a bracket, and I'm going to write 2 bracket, and then I'm going to write these first three terms as x take away 3 quantity squared. And then the little negative 9 is off to the side, and then the parentheses is of course the bracket. So plus 13. So basically I wanted to add a 9, but to keep things balanced, that is to keep a 0 here, I had to subtract a 9 as well. So the positive 9 that I added is the only thing that gets included in when the square has been completed. So I have that residual negative 9 there. Now it's important that these are still brackets because I then want to take that 2 and distribute it because it's a difference right there. So I'm going to multiply the 2 right here by that term, and then I'm going to multiply the 2 by the 9. So this becomes 2 times x minus 3 quantity squared minus 18, right? 2 times negative 9 is negative 18, and then plus 13. And then I can add these last two terms together. So I have 2 times x minus 3 squared minus 5, okay? And that's my parabola in standard form. So remember, standard form was f of x equals a times x minus h quantity squared plus k. And so that's the form I have. And when it's in that form, I can now see a few things, right? First of all, I see the vertex right away. The vertex is the ordered pair, well, HK, in this case, 3, negative 5. So it's 3, comma, negative 5. And then now every parabola has either a maximum value or a minimum value. And if it opens up, it's got a minimum value, the vertex, right? The y-coordinate of the vertex. And if it opens down, it's got a maximum value, which is, again, the y-coordinate of the vertex. So let me say that again. If the parabola opens up, it has a minimum value, and that's the y-coordinate of the vertex. If it opens down, it has a maximum value, which is the y-coordinate of the vertex again. So in this case, because A is positive, right? A is 2, I know that this parabola must open up. And if it opens up, then it has a minimum value. So it opens up, therefore the minimum value is going to be the y-coordinate of the vertex, which is negative 5. The minimum value of negative 5. Let's see, x-intercepts, we'll go ahead and we're going to need a little more space for that. So let's go ahead and find the x and the y-intercepts on a separate page, and then we'll sketch the graph of this thing. So what we have is this parabola, and the vertex is 3, negative 5. Let's go back for a moment. What was it in standard form? What I just did, I got 2 times on the previous page x minus 3 squared plus minus 5. So this is the standard form of that vertex. Okay, let's go ahead and find the y-intercept first, because that's easier. So to find the y-intercept, actually this first form is easy. Is easiest to use. All you have to do is set x equal to 0. So when you find the y-intercept, you set x equal to 0, and you get y is equal to positive 13. And so the y-intercept has coordinates 0, 13. Now let's find the x-intercepts, if there are any. So to do that, there are a couple of ways to do it. We're going to set the y-coordinate equal to 0. So you set y equal to 0, and now we've got to solve the equation 0 equals all of that. So 0 is equal to 2x squared minus 12x plus 13, and see if it has real solutions. So we'll use the quadratic formula. So we have x is equal to negative b, so 12 plus or minus the square root of b squared is 144 minus 4, and a times c is 26. And then all over 2a, all over 4. So x is equal to 12 plus or minus the square root. Let's see, 144 take away, what's that going to be, 104? All over 4. So we're looking at x is equal to 12 plus or minus the square root of 40 over 4. And let's simplify that. So let's go ahead and do that up here. So we're looking at x is equal to 12 plus or minus, and this radical can be simplified as 2 square root of 10, and then all over 4. And then I can factor out a 2 from the numerator. So it's going to be 2 times 6 plus or minus root 10 over 4. And then I finally cancel a factor of 2 from the numerator and denominator. So we get x equals, well, 6 plus or minus the square root of 10 all over 2. Now, this is as simple, as exact as you can write it. And the square root of 10 is irrational. Now, these intercepts, these numbers happen to be x is about equal to 1.42. This is where the parabola crosses the x-axis. 1.42 and 4.58. That's what you do when you get decimal approximations using a calculator here. Okay, let's go ahead and put this all together and see what our graph looks like. So we have the x-intercepts, we have the y-intercept, we have the vertex. Let's go ahead and see what this thing looks like now. Okay, so I'm using a program called Desmos, which is an online free graphing calculator, which is awesome. And so all I did is I typed in my parabola, my original parabola, and let's see if it has the features that we thought it should have. The vertex is 3, negative 5, which we found. The y-intercept was 0, 13, which we found as well. And the x-intercepts, 1.42 was the first one we found, and 4.58 was the second one we found. So, and of course you can change the settings on Desmos by hitting this little wrench, and you can adjust things on it. but it basically has the features we want, and we're going to be using Desmos at different times throughout our course and for graphing complicated functions. It's free, so go ahead and practice with it now. All right, until next time.